Question 5 offers us a vectors question. We've got 4 points, all described in terms of I and j, and we've been asked to show that the line from A to D is parallel to the line from B to C. Personally, I get a lot of confidence by drawing the rough system out here. So there's the system, not drawn to scale, and we've been asked to prove that the line BC is parallel with BD. So to prove two vector lines are parallel, the ratio of the two I components compared with the ratio of the two j components should be equal. So I need to find effectively the gradients of both of these lines. So first of all, let's do A to D. So the journey from A to D is that we've gone along 10i and we've gone up 24j. Now the journey from B up to C. In I terms, we've gone along from 0 up to 50, so we've gained 50i. And in height terms, we've gone up from 16 to 136, so we've gained 120j. So hopefully you can see, if I multiply the first vector by 5, I will get to the values of I and j here. 5 times 10 is 50, 5 times 24 is 120. So given that we can do that, these lines are indeed parallel. So we've proved what was required in part A. Now let's have a look at part B. They're now saying that ABCD, which is this quadrilateral here, is now a running track. And the runners run along all 4 sides. The lengths of the sides are measured in meters. Given that a particular runner takes exactly 5 minutes to complete 2 laps, calculate the average speed. But careful, we need the answer in kilometers per hour. Okay, let's work out the distance of all of these 4 lines. The distance is described as the modulus of A and D, and this is found by squaring both of the individual components of the vector and then square rooting the result. So this is equal to 10 squared plus 24 squared, and then taking the square root. BC, because we've done effectively the maths already, is the individual squares of 50 and 120, and then the square root of both of them. We need to do a bit of side work just to work out the vectors of the 2 remaining sides. One of those 2 remaining sides is DC. The increase in I is 50 minus 22, so this is 28i, and the increase in j is from 24 up to 136, which is 122. And our last remaining line is AB. As we travel from A to B, we go back negative 12i and up 16j. So we need to work all of these out. This is 26, this is 130, this is 28 root 17, and this is 20. So bringing all this together, I get that the distance is equal to all of these added up, and we've got to multiply those by 2. We've got to divide that sum by 1,000 to get to kilometers, and that's divided by the time, which we're told was 5 minutes, and we've got to divide that by 60 to get to hours. Pop that all into a calculator and get 6.99, and on it goes, and this is kilometers per hour. And that's the answer. Just to say, you could have expressed all of these vectors here as column vectors and worked out the distances from there, but I think with 2 dimensions it's probably easier to stay in a linear expression using i's and j's rather than column vectors, but the choice is entirely up to you.